Good day everyone, my name is Flores and welcome back to my YouTube channel. For today's video, I am going to discuss about application of integration. And the objective of this video is that at the end of this video, the learners are now able to find area between curves, since the main focus of applying integration here in my video is to find the area between curves. But before that, or before we proceed, let us first discuss about area between curves. Area between curves, we are able to solve this if f sub 1 of x is greater than or equal to f sub 2 of x throughout the interval of a, which is less than or equal to x, and x is less than or equal to b. The area between the graphs of f sub 1 and f sub 2 from a to b is the integral of the quantity of f sub 1 of x, which is less than or equal to f sub 2 of x dx from a to b. And by that, we came up with this formula of solving the area, which is the integral of f sub 1 of x minus f sub 2 of x dx from a to b. In order for us to solve or to apply or to evaluate application of integration in solving area between curves, we should apply the given formula in this given examples here. First is find the area of the region bounded by the parabola y is equal to 2 minus x squared and below by the line y is equal to negative x. Solve y is equal to 2 minus x and y is equal to negative x simultaneously. And by that, we came up with this given here. So we came up with 2 minus x squared is equal to negative x. Combined or apply additive inverse, so we came up with x squared minus x minus 2. So and x squared minus x minus 2 is as good to be factored. So we came up with the factors x minus 2 and x plus 1 is equal to 0 for us to find the value of x. So we came up with x, which is equal to 2, and the other x is equal to negative 1. And by that, we have given. This is the graph of the given. We have this parabola and the line, which is equal to negative x. The area, which is the formula given a while ago, we have the integral of f sub 1 of x is equal to f sub 1 x is equal to f sub 2 x dx from a to b. So that we came up with this format. Just substitute the value of our 2x. So we came up with negative 1 and 2, and our value of our parabola, the line of parabola, and the line which is equal to negative x. So we came up with the integral of the quantity of 2 minus x squared minus and the quantity of negative x dx from negative 1 to 2. So we came up with the integral of 2 minus 2x squared plus x dx from negative 1 to 2. And by that, just substitute the values, the integral signs. So for applying the properties, if you still remember in the indefinite integral video, we have this property that distribute the integral signs. So we came up with the integral of 2 dx from negative 1 to 2 minus the integral of x squared dx from negative 1 to 2 plus the integral of negative 1 and the integral of x dx from negative 1 to 2. So we came up with this 2x minus x cubed all over 3 plus x squared all over 2 from negative 1 to 2. And by that, we just substitute negative 1 and positive 2 to our values. So we came up with 2 multiplied by 2 minus 2 cubed all over 3 plus 2 squared all over 2 minus the quantity of 2 multiplied to negative 1 minus negative 1 cubed all over 3 plus negative 1 squared all over 2. And if we simplify or solve that, we came up with 9 all over 2 units squared. as the value or the area between the parabola line of 2 minus x squared and the line y is equal to negative x. Next is find the area of the region bounded on the right by the line y is equal to x minus 2, on the left by the parabola x is equal to y squared, and below by the x-axis. So we have this given here. The y plus 2, which is the right line or the line, and the y squared as our parabola. By that additive inverse, we came up with y squared minus y minus 2 is equal to 0. And again, it is good for factoring. So we came up with these factors. Y is equal to 2, y minus 2, and y plus 1. And then it provides, or it gives the values of 2 and negative 1. So this is the graph of the given. The y squared, the parabola, and then the line, which is the x minus 2, right? The y plus 2 rather. So we came up with this graph. So again, the area is equal to the integral of the quantity f sub 1x minus f sub 2x dx from a to b. And from the given, so we came up with negative 1 and 2 as our limits. Negative 1 from negative 1 to 2. So we came up with the integral of y plus 2 minus y squared dy, the dy from negative 1 to 2. And if we solve that, we will solve out the same process with a while ago, that we substitute, or we distribute rather, the integral signs. So we came up with integral of y dy from negative 1 to 2 plus the integral of 2 dy from negative 1 to 2 minus the integral of y squared dy from negative 1 to 2. And if we solve that, we will come up with y squared all over 2 plus 2y minus y cubed all over 3 from the limits of negative 1 to 2. Again, just substitute the given, or the limits, negative 1 and 2, to our values. So we came up with 2 squared all over 2 plus 2 multiplied by 2 minus 2 cubed all over 3 minus the quantity of negative 1 squared all over 2 plus 2 multiplied to negative 1 minus negative 1 cubed all over 3. And if we solve that, we're going to come up with this value as the area of the value of, as the measurement of the area between the parabola and the line, which is the 9 of all over 2 units squared. And that will be all for today's video. Thank you and God bless.